Hello, and welcome to the first video portion for the Drawings Lab. Today, we're going to be covering detail drawings. Drawings are the last new file type in SolidWorks, and they allow us to provide a 2D representation of a 3D part, often used for manufacturing or informational purposes. When producing a detail drawing, it's often helpful to have the part file that you want to create a drawing of open before you begin. This makes it easier to find in the later steps. When we first go to open up a new drawing file, we're going to get this pop up. I'm going to ignore it for now. Next, it asks us which SolidWorks file we would like a drawing of. I'm going to close out of this for the moment, so that we can start by editing our settings. To begin, let's take a look at the size of our drawing. We can right-click on the sheet and select Properties, and then from here we can set the dimensions of our sheet. I'm going to set mine to 11 inches by 8.5 inches, so that it'll print better on standard paper. The choice for paper size is usually going to be dictated by the company that you are working with. The standard 17 by 11 or 11 by 8.5 will work well for this class. Once we have our dimensions set, we can hit Apply Changes and start looking at some of our other options. We can enter the options by selecting the gear icon up at the top of the screen. Let's begin with Tangent Edge Visibility. This is in the System Options, under Drawings, Display Style. These allow us to set a default for the drawings, which is usually going to be tangent edges removed. We can always set specific views to have an exception, but this will keep us from having to manually set the tangent edges for each view. Next, on Document Properties, we can specify our drafting standard, which should usually be ANSI, our units, which should match up with the part, in this case inches, and we can explore some of the other options if we need to. Once we're happy with all of our settings, we can select OK to get started. To get our first views, let's import our part. We can go to the Drawings tab up on the ribbon and select Model View. If we already have our part file open, it's going to show up in the Open Document section. Otherwise, we're going to need to browse for it. Once we have that selected, we can hit the little right arrow up at the top right to continue on to the next step. There's a lot to see, so let's start at the top. First, we can choose our configuration. Since my part just has one configuration, there's only one option available. Next, we can choose which views we want it to generate. I want this to generate multiple views, so we're going to check the Create Multiple Views box first. Generally, we're going to want a top view, a front view, a right view, and some form of pictorial, in this case an isometric. Continuing down, our next useful option is going to be Display Style. This sets the default, but exceptions can be made for each view. Since 3 of these views are going to be standard views, let's set Hidden Lines to Visible. Next down, we can set the scale. This is often going to be more of a by-feel kind of thing. You usually want the scale set so that each view is large enough to be useful. So I'm going to set mine to use Custom Scale, and then we can choose the scale that we would like from the drop-down menu. Here I believe 1:2 ought to fill the page nicely. If you don't see an option that you're happy with, you can always just type in the scale value that you want. That covers all of the useful options on this menu, so now we can hit our little checkbox in the top left to set our views. Okay, these look alright, but it still needs some work. First off, we can see that there are hidden lines in our isometric. The convention is that pictorials don't have hidden lines unless we have a really good reason, and here they're just cluttering up the view. We can choose the isometric view by left-clicking on it, and then on the left-hand side, we can set it to Hidden Lines Removed. That still doesn't quite look right. Let's add the tangent lines back in. We can do this by right-clicking on the isometric view, selecting Tangent Edge, and choosing Tangent Edges with Font. Cool, that's looking a lot better. Some of these views are a little bit cramped together, so let's space things out a bit more. Drawings are a little bit more of an art than a science, so we can just left-click drag to move some of these views into better positions. One thing to notice is that multi-views are all linked together. This is to enforce the usual norms for drawing layout. The right view is directly to the right of the front view, and etc. So, we have a few things that could be clearer. We can't really see the slats on the inclined surface very well, and it's a bit difficult to tell what's going on inside the part. We're going to need to add some additional views. Let's do the inside first. This is best done with a section view. We can create a section view by selecting the Section View button up on the Drawings tab of the ribbon, and then choosing the cutting line that we want from the sidebar. Usually, we're going to choose either the horizontal or the vertical option, but we do also have the choice to set an Align Section View, an Auxiliary Section View, or one of the many forms of half sections. Details for all of these section options are available in the lab chapter. Then, by hovering over the view that we want to section, we can left-click to place our cutting line. If we want, we can add an offset portion to the section line, but in this case, that's not really necessary. We can hit our checkbox to confirm, and then left-click to place the view. In this case, our section is going to make the front view rather redundant, so we really don't need both. So what we're going to do is hide the front view by right-clicking on it in the design tree and selecting Hide. Then we're going to position our section view to take its place, making sure that it's aligned properly with the right view. Next up, let's add our slats. Since they're on an inclined plane, we're going to need an auxiliary view to see the features in true size and shape. For this auxiliary view, we're going to select the auxiliary view button, and then select the edge that the view folds out around. From here, we can left-click again to place it. We can see that creating this view also adds an arrow to show us where the view came from, and a note. Since the auxiliary view is fairly easy to place, we can get rid of the arrow by unchecking the arrow box over on the Properties Manager, and then we can delete the note by left-clicking on it and hitting the Delete key on the keyboard. From here, we can adjust some of our other views to make space, and make sure that we can see everything properly. This is giving us a complete auxiliary view, which is often going to be unnecessary. It would be handy if we could do a partial auxiliary view of this surface to just show the features that will be true size and shape. SolidWorks does not have a built-in method of doing partial auxiliary views, but we can crop the view in order to remove the excess details. In order to do this, we must first left-click to select the surface that we want the partial auxiliary of, then go over to the Sketch tab on the ribbon. From here, we can choose the Line tool to allow us to outline the surface that we would like our auxiliary view of, in this case making sure that we use the guidance pips to help us line up our geometry. And then once we've closed the contour, we can pop back over to the Drawings tab and select Crop View. This is going to automatically trim away all of the extra edges and leave us with just the desired surface. Okay, what next? The little hole at the bottom is going to be a little difficult to see in this view, so let's add a Detail View. We can select the Detail View button up on the Drawings tab of the ribbon, left-click to place the center of the detail view, and then left-click again to specify the radius of the circle. This gives us a detail view stamp that we can place somewhere else on the drawing. Let's put it here. From there, we should adjust the callout so that the letter doesn't overlap with any of the model geometry, and then we can look at the scaling. Here, it's chosen a good scale for us automatically, but if we want to adjust the scale, we can left-click on the detail view and modify the scaling from this text box here. As a quick aside, this is going to give us Detail View C, skipping the letter B entirely. This is kinda sloppy, so what we can do to change it is select the view, and then edit the detail circle section here to say B instead. There we go. That takes care of our views. Now we just need to add in all of the dimensions, the callouts, the center lines, and the center marks. Let's do the center lines and center marks first. Both live under the Annotations tab on the ribbon. We're going to select the center mark button, and then left-click on every instance of a circle where it's shown in true size and shape. In this case, we only need to add these two manually, as this one was added automatically. If necessary, we can hit the Escape key to deselect the tool and left-click on a center mark and modify its display attributes from here. Similar to view placement, this is also somewhat by feel. You want to make sure that the extension lines hit the circle, but don't go completely overboard. For the center lines, we're going to select the Center Line button up on the ribbon and check the Select View under Auto Insert. This makes it so that when we left-click on a view, it's going to automatically add all relevant center lines. Of course, sometimes this option does go a little bit overboard and add some center lines that aren't particularly useful. In order to get rid of them, we can hit the Escape key to deselect the tool and left-click on the center lines and remove them via the Delete key. Center lines can also be added manually. This can be done by making sure that the Select View box is unchecked, and then you can left-click on one edge and left-click on another. And this is going to generate a line that goes right in between the two of them. Sometimes center lines can be used as a way to show symmetry, in this case showing us that this entire surface is symmetric across this bisecting line. Center lines added manually often need to be adjusted in order to have the desired length. This can be done just by left-click dragging on the endpoints. Next up, let's add our callout. We have a hole wizard feature that was used to create the central hole. We can automatically generate a hole callout by selecting the Hole Callout button up on the Annotations tab, and then left-clicking on the central circle. From here, we can left-click once more to place the callout, and hit the Escape key to deselect the tool. Now, the last and most tedious part. We need to add in all of the dimensions. From here, we're going to select the Model Items button on the Annotations tab. Then we're going to go to Source and set this to Entire Model, and check the Import Items into All Views box. Continuing down, we want to make sure that we have the Hole Wizard Location option selected, and then we can hit our green check mark. Cool, done. Of course, we still need to move all of the dimensions to the views where they make the most sense, and make sure that they're following the standard conventions for dimension placement, but the lion's share of the work is done. We can left-click drag on the numbers to move them around into a position where they're not breaking any of our dimension placement rules, and you can hold down the Shift key while left-click dragging on a dimension to move it from one view to the other. The important part while we're cleaning up our model is to make sure that each of the numbers is readable and that it's easy to tell what the number is supposed to be defining. On occasion, there will be dimensions that you want to add notes to. Here, we have a dimension that's defining our fillet radius. We can see that SolidWorks has recognized what it is that this dimension is supposed to be describing and added the TYP tag onto the end of it. standing for typical, meaning that the fillet radius is going to be 0.5 across the entire model. In cases where a note needs to be added to a dimension that hasn't been added automatically, we can left-click to select the dimension and then add that note in the dimension text, while ensuring that we leave the automatically generated text alone. Next up, we may want to specify the shell thickness in a note, instead of with this dimension. We can add notes by going to the Annotations tab and selecting the Note button. From here, we can left-click somewhere on the drawing to place it, and then type in the value that we want it to have. In this case, shell thickness 0.3 inches. Now that we have that, we can delete the 0.3 that we have over here via left-clicking on it and hitting the Delete key on the keyboard. Before we get too much further, a brief description of what we've done so far. The Model Items button goes into your actual part file and produces a dimension for each dimension used while creating the part. So every single dimension used to define the model should show up, but on occasion they might not be there. If something is missing, you can manually add it by using the Smart Dimension tool. Use this only as a final resort, as smart dimensions do not preserve bidirectional associativity. With imported dimensions, if we modify any of them in the drawing, they will get updated in the part file, but the smart dimensions only exist within the drawing, so they can't modify the part file. Additionally, some dimensions may resist being moved into a more useful position, like the 0.2 here. In cases like these, it is often going to be the best to just delete the dimension and use the Smart Dimension tool to manually re-add it in the view where it will be the most helpful. Additionally, some dimensions like this 0.1 can be moved into the proper view, but it's difficult to tell exactly what it is that this dimension is defining. Similar to the 0.2, we can just delete that dimension and use the Smart Dimension option to add it in ourselves. Once you've positioned all of your dimensions in ways that is going to make them easy to read and put them in views where it's going to be easiest to interpret what it is that they mean, the next step is general cleanup. Here it's going to be important to make sure that we are following the standards for dimension placement. The leaders should have gaps before the things that they're dimensioning, and the dimensions should be centered on their leaders. A quick way to modify the leaders is to just left-click to select a dimension, and then left-click drag on the little blue rectangles to move them to a place where we will have that gap. A quick way to center all of your dimensions is by hitting the Ctrl-A key on the keyboard, right-clicking, selecting Display Option, Center Dimension. This will automatically move each dimension to the center of its little leader set. I'm going to do a quick skip to move us to the point where all of our dimensions are properly positioned and defined. There we go. That looks much better. Well, that about covers everything that I had for today. Have a good day. We'll see you again next time.